Okay, hi guys. Here is our first of hopefully many successful lectures using a screen recording. We'll see how this goes. So, today we will be covering section 4.1, which will be Maxima and Minima. That's just the plural form of maximum and minimum. So we know that what we've been talking about this semester is derivatives. That's all Calc 1 is. And we know that the derivative is just the slope of the tangent line. Right, that's just like the basic idea of it. And so we can actually use this to find the minimum and the maximum of functions. So I'm going to give you guys a graphic example. Let's see how this goes. So if I have some function, f of x, and let's say it looks like this. This is just a convenient example. It could be any function. Right, and let's say this is a and this is b. Doesn't really matter, just lets us know where we're defining our function. If I were to ask you guys where to find the minimum, or if you were to find the minimum and the maximum of this function, hopefully you would tell me that the maximum is here and that the minimum is here. So the way that we find this using the derivative, or the slope of the tangent line, is note how if I were to draw the tangent line in here, let's do green. If I draw the tangent line in here, the slope of that tangent line is 0. And it's the same case over here. That's because to have a maximum, first of all, to get to a maximum, you have to be increasing, right? So we're increasing, we're increasing, we're increasing, we're increasing. And then when you hit the maximum, we have to decrease, because if we kept increasing, it wouldn't be the maximum. There'd be a number higher than it, right? So once I hit my maximum, I stop increasing. And in order to switch from a positive slope to a negative slope, you have to go through 0. It's just like on the number line. To go from a positive number to a negative number, you have to go through 0. Same if we were going from, the same deal is for a minimum. We have a negative slope to get to our minimum, but as soon as we hit our minimum, we suddenly have to have a positive slope, because otherwise it wouldn't be the minimum. There'd be something below it. And so we have to go through a slope of 0 in order to have that switch. So hopefully that kind of makes sense. However, I'm hoping you guys are kind of intuiting. We have a problem, and it is that we have slopes of 0 in other locations. So right here, well, I drew that badly, but we have a slope of 0. And right here we have a slope of 0. But those aren't our minimum or maximums. We know that this guy's higher. This is higher. And this is lower. So we need to figure out what we're going to do about these guys. This is also over here. The way I drew it has it. I didn't intend to draw it that way. Anyway, so I'm going to give you guys a couple definitions for a more formal approach to this. So let's see here. First of all, I'm going to define absolute maximum and minimum. So an absolute maximum is, let f of x be defined on A to B. So that's like this guy up here. We have our function being defined from A to B. And let C be in that interval, A to B. So I guess you could say let X equal C be in that interval. If our function at C, so f of C, is greater than or equal to all the other points of our function for all x in a b, that's just saying all of the other x values we defined, then f of C is an absolute maximum on D. Okay, and for the definition of an absolute minimum, it's the exact same thing, except it's if f of C is less than or equal to all of our values of our function. Then it would be called an absolute minimum. And these two form together for a new definition, which is absolute extrema. So absolute extreme value. Technically, it would be absolute extremes or extreme values if we're talking about more than one, because we have an absolute minimum and an absolute maximum, and they're both extreme values. And another way to say this is absolute extrema. Again, extrema is just the plural form of extremum. Okay, so the absolute extreme values are just an absolute maximum or an absolute minimum. All right, so up here where we were drawing on this graph, this is technically an absolute maximum and an absolute minimum. Absolute is just saying for all of these values of x, this is the the highest maximum, and this is the lowest minimum. So, because there's something specific like the absolute maximum and an absolute minimum, there's probably a different kind of absolute, or a different kind of maximum and minimum, and that's what we're going to talk about next. That is local maximum and local minimum. So local maximum, that is, if we look back up at our graph, that's this point. Because if I were to cut my graph into pieces and only focus on this section, this point where the slope is 0 is my maximum. So it's my maximum in this local area. Just like this guy here is my minimum in this local area. So if we cut out the parts where the absolute maximum and the absolute minimum are, then these are our local maximums and local minimums. Technically, absolute maximums and absolute minimums are local maximums and minimums, but you wouldn't really call it that. So, let's see here. I'll define that for you guys a little bit better. Let f of x be a function defined again on AB, and let C, or I guess x equals C, be an element of, we'll say, let's see here. We'll do C sub 1 to C sub 2. So that's saying if I have my number line, and this is A, and this is B, I'm going to define an element of C sub 1, C sub 2 within A to B. So that's saying within this A to B range, I have C sub 1 and C sub 2, and my value C is in here. It doesn't have to be the center. But yeah, so that's this guy. And A to B is this whole thing. I guess technically not where I drew it. That guy. Okay. So anyway, it's basically the same as the absolute maximum, except that we're restricting our x values to a smaller area. So if we're letting C be an element within this smaller interval, if f of C, again, is greater than or equal to f of x for all x in C1 to C2, then f of C is an absolute maximum. Or sorry, is a local maximum. On C1 to C2. Also up here, I shouldn't have written D. I should have had A and B. So that was a typo, but writing, so write-o, unknown. Anyway, so that's your definition for local maximum. Local minimum is defined, again, basically the same. Except that it'll be f of C is less than or equal to f of x for all x in that interval. And as you might anticipate, these form together to be local extrema. Okay, so that's just a little bit of our terminology. And I'm actually going to stop this video here because I'm hoping that it will load better if I break this into multiple sections. So those were basically the setup definitions for what we're talking about. And now we're going to get more into the theory about like how to find these absolute values, or these absolute maximums and minimums, and these local maximum and minimums without actually like looking at a graph. So please click on the next video for that information.